This is our third video in our AMC series. Today we're going to be going over number theory, permutations, and combinations. Number theory. Number theory is the study of the set of positive whole numbers. These are the types of numbers. It's going to be helpful to know this for your AMC exam. Natural numbers are 1, 2, 3, 4, 5, 6, 7, and on. Odd numbers are 1, 3, 5, 7, 9, 11, and on. Basically numbers that are not divisible by 2. Evens are the opposite of odds, 2, 4, 6, 8, 10, divisible by 2. Squares are numbers like 1, 4, 9, 16, 25, 36. Basically, 2 squared is 4, 3 squared is 9, 4 squared is 16. Like that, these numbers are squares. Cubes. Cubes are just like squares, except it's something cubed. 2 cubed is 8, 3 cubed is 27. Prime numbers are numbers that are only divisible by 1 and itself. Composite numbers are the exact opposite of prime. If a number is congruent to one model of 4, it means that when that number is divided by 4, it leaves a remainder of 1. Examples are 1, 5, 9, 13, and on. If a number is congruent to 3 model of 4, it means that when it's divided by 4, it leaves a remainder of 3. Here are examples. Perfect numbers. Perfect numbers are numbers where sum of all its divisors, other than itself, adds back up to the original number. These are certain examples. Fibonacci. Fibonacci numbers is a series where if you take a number, the sum of the two numbers before it makes that number. 2. 1 plus 1 makes 2. 5. 2 plus 3 makes 5. Okay, first problem. A 2-digit number is such that the product of the digits plus the sum of the digits is equal to the number. What is a units digit of the number? We're going to take our 2 digits as A and B. So this number is equal to the product A times B plus the sum A plus B. And equal to the number. So you're going to be wondering, why is there a 10 before A? A is in the tens place. So if you just take a number like 56, that 5 is not equal to 5, it's equal to 50. So that's why I'm multiplying 10 to give its proper value. Now, we're going to write it without the parentheses. AB plus A plus B equal to 10A plus B. If we take B to the side, both of them are going to cancel out. So we're going to go ahead and do that. Now we can write this as a distributed A times B plus 1, because there's 2 terms, equals to 10A. You can divide both sides of A. So there we go. So B plus 1 is equal to 10. That means B is equal to 9. And that's our answer because B is our units digit. E. Problem. The 7-digit numbers 74A52B1 and 326AB4C are each multiples of 3, which of the following could be the value of C. So that means these numbers are divisible by 3. 3's rule is that the sum of the digits of a number should be divisible by 3 for the number to be divisible by 3. So our first number, 74A52B1, and our second number, 326AB4C. So the sum of these numbers is 19, A plus B. So the possible sums that you can get are 21, 24, 27, 30, 33. Of course there is more, but we're going to stop here for this problem. So this is 21, A plus B is 2, 24, 5, 27, 8, 30, 11, 33, 14. Now our next number. The sum of this is 15. A plus B, C possible ones here are 18, 21, 24, 27, 30, and 43. So now, if this is 15 and has to become 18, that means this is 3. And just like we're going 3 more, we're going 3 more here. 3, 6, 9, 12, 15, 18. Now here's the possible values of a plus b. So for here, the total has to be 3. And possible is a plus b is 2. If a plus b is 2, 3 minus 2, c is 1. For 21, we need 6, 5, 1, 24, 9, 8, 1, 27, 12, 11, 1, 30, 15, 14, 1, and if we went one more, this would be 17, so we can go 17 and 1. So as you see, there's a pattern. C is always 1. So when they're asking which of the following could be a value of C, so 1 could be a value of C. Next problem. A palindrome is a number that has the same value when read from left to right or from right to left. For example, 12,321 is a palindrome. It's read the same both ways. Let n be the least 3-digit integer, which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? It's important to understand the last part because this problem has a lot of steps. All 2-digit palindromes are divisible by 11. Let me show you. 11, 22, 33, 299. So because n is the sum of 3 2-digit palindromes, that means n is also divisible by 11. So the least 3-digit integer that is divisible by 11 is 110. So n can possibly be 110. But to make sure, we need to check if there are 3 different 2-digit palindromes which make up 110. First, we know that 99 plus 11, both palindromes, make up 110, but these are only 2. But we can split up 99 into 77 and 22. So that means n is 110. But importantly, what they're asking is, what is the sum of the digits of n? So 1 plus 1 plus 0 is equal to 2. So our answer is A. Permutations and combinations. In permutations, the order matters. It's an ordered combination. Combinations, the order does not matter. So we're going to do a practice problem. Arrange 5 people next to each other. How many distinct arrangements can we make? This is a permutations problem. So there are 5 people, we're going to put 5 slots. 1, 2, 3, 4, 5. In the first slot, we can have 5 different people. So 5 is a possibility. For this one, there's only 4 because one person is already sitting down. 4. Just like that, people sit down, so 3, 2, and 1. So this is equal to 5 factorial, which is equal to 120. The general formula for this is the number of distinct permutations of n objects is equal to n factorial, which is exactly what we did here. Another practice problem. From 1, we want to make an arrangement of 3 at a time. So if you remember, we have 5 people, but we want to make arrangements of 3 at a time. So we have 3 slots. We can still have 5 for the first one, then 4, then 3. You're just not including all the people. This is equal to 60. So if you look at the formula now, for the general formula, the number of distinct permutations of n objects taken k at a time is equal to n factorial over n minus k factorial. We're going to use this formula. It's still going to get the same answer. So n is 5 factorial over 5 minus k factorial. Oops, my bad. 5 minus 3 factorial, which is equal to 5 factorial over 2 factorial. So then this will be equal to 5 times 4 times 3, which is exactly what we got here, which is equal to 60. Another problem. From 1 and 2, instead of arrangements, say we want to make a group of people of 3 from a total of 5. How many such distinct groups can be made? Because in groups, the order doesn't really matter, you can see this as a combination. So, from a group of 5, we're choosing 3. So it'll be 5 choose 3, which can also be written as 5 choose 3. So this is a formula for this. I'm going to explain this because I'm going to use this formula. So n factorial over k factorial times n minus k factorial, which in our case is going to be 5 factorial over 3 factorial times 5 minus 3 factorial, which is 5 factorial, 3 factorial, 2 factorial. And I'm going to write this as 5 times 4 times 3 factorial over 3 factorial, 2 factorial. So this is easier to see that this cancels out. So it's going to become 20 over 2, which is equal to 10. Just a small tip on this. N choose k is equal to n choose n minus k. So if we're going to have problems, we can take from our previous problem 5 choose 3. So 5 choose 3 is equal to 5 choose 5 minus 3, which is, so 5 choose 2. Okay? So 5 choose 2 is going to be equal to 5 factorial over 2 factorial. Then 5 minus 2 factorial is 3 factorial. So now 5 choose 3. So 5 choose 3 is 5 factorial over 3 factorial. 5 minus 3 factorial is 2 factorial. As you can see, these are both the same thing. Next problem. Every day at school, Joe climbs a flight of 6 stairs. Joe can take stairs 1, 2, or 3 at a time. For example, Joe can climb 3, then 1, then 2 stairs. In how many ways can Joe climb the stairs? So Joe needs to land on that last step. There is 2 to the power of 5, 32 ways to cover those other 5 steps. But this includes not only 1, 2, 3, but includes 4, 5, 6. So we're going to just jump 6. So we need to take out those invalid ones that use 4, 5, and 6. So for 4, the invalid would include 4, 1, 1, 1, 4, 1, 1, 1, 4. Then 2, 4, and 14. So that's for 4, that's the invalid ones. For 5, it's just 5, 2, and 2, 5. So for 5, invalid ones are 4, and 2 for 5. For 6, there's only 1. So there's a total of 5 plus 2, 7, 7 plus 1, 8 invalid ways from these 32. So we take those invalids out, 32 minus 8, which is 24. So there's 24 valid ways. Another problem. So the phases of each of 2 fair dice are numbered 1, 2, 3, 5, 7, and 8. When the 2 dice are tossed, what's the probability that their sum will be an even number? So to get an even number, you're either going to have 2 odd numbers or 2 even numbers. So we're going to look at that. So odd. Because both dice have the same numbers, we find for 1, just multiply. For odd, out of 6. So probability is always probable outcome over total outcome. So 6 is a total outcome and this will be the probable outcome. So there is in here 1, 3, 5, 7, which is 4 odd numbers. So 4 out of 6 multiplied with the other die, 4 out of 6, which gives you 16 out of 36. Probable, and this one would be the total. And then for even, there's still out of 6, but there's 2 8, only 2. 4 out of 36. Here, this one's the probable, this one's the total. So the total is 16 over 36 plus 4 over 36, which is equal to 20 over 36, which we simplify to 5 over 9, which would be C. Next problem. Abby, Bridget, and 4 of their classmates, a total of 6 people, will be seated in 2 rows of 3 for a group picture as shown. If the seating positions are assigned randomly, what is the probability that Abby and Bridget are adjacent to each other in the same row or the same column? So first, for probability, it's always probable over total. So first we're going to find out the total. So for the total, if we just take Abby and Bridget as one in this problem, it's going to be easier. So here we have 6 total. I that we're choosing 2 to be together. 6 choose 2, which is also 6 choose 2, is equal to 15. So 15 is our total. Our total is 15. Now, probable. For them to be together, there's 1, 2, 3, 4, 5, 6, 7 possible. So the probable is equal to 7. That means the probability is the probable 7 over the total 15, which is C. Almost done. A box contains 5 cards, number 1, 2, 3, 4, and 5. 3 cards are selected randomly without replacement from the box. What is the probability that 4 is the largest value selected? So first we're going to find the total value, always a probability as we talked for the 2 prior problems, that first we need to find a total. This one, it's 5 choose 3. 5 choose 3 equal to 5 choose 3 is equal to 10. So 10, our total is equal to 10. Now the probable. So if 4 is the largest one selected and 3 are selected, the other 2 has to be 1, 2, or 3. So from the 3 possible, now we're choosing 2. And 3 choose 2 is equal to 3. And this is our probable. So that means our probability is going to be our probable over our total, which is equal to 3 over 10, which is equal to C. Our last problem. An ATM password at Fred's Bank is composed of 4 digits from 0 to 9, with repeated digits allowable. If no password may begin with the sequence 911, then how many passwords are possible? So the first 3 digits, there's 10 that's possible for each, so there's a total of 10 to the cubed, which is 1,000 possibilities. But out of those 1,000 possibilities, 1 is not possible, 911. So minus 1 is equal to 999. Then for the last digit, there's 10 possibilities. So we're going to do our 999 times 10, which will be equal to 9,990, which is D. Thank you for watching. I hope you learned something. Please be with us for our next and 4th video, which will be on geometry and ratio of geometric areas. Thank you, bye! Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!